Hello students, welcome to Learn with SAS. So in this video, I will go through the basic concept of quadratic equations. So if you are looking to understand the quadratic equations from scratch, please stay tuned with me. So, when we talk about quadratic equations, right? So, we always think, what is that, right? So, you think about like an equation like this. Suppose the equation is like this: x square plus x plus 1 is equal to 0, right? So, if you see the highest degree in the variable x is 2, right? So, whenever uh, we have an equation that have the highest degree of 2, right? So then we call that equation as a quadratic equation, right? This is the only definition you should understand. Okay. So if you have any equation that is having the highest power of x as 2, then that is a quadratic equation. And the standard form of quadratic equation is ax square plus bx plus c is equal to 0. Okay, where a is not equal to 0, right? It means that uh, if you put the value a is equal to 0 in above equation, what happens? It vanishes the x square, right? So then this equation cannot be called as a quadratic because it becomes like a linear equation, right? So this is the meaning of a not equal to 0. So whenever you study any equation or any concept and there are some conditions like there, okay, like this over there, then it should be very clear what is the meaning of this condition, right? So that's how. So this is the standard form of the quadratic equation. So this is very important to remember always. Okay. So now let us see some quadratic equations and understand whether they are quadratic or not. For example, suppose you have a equation like this: x cube plus x square plus x plus 1 equal to 0, right? So now you will say, sir, this equation has the power 2 of x, right? It is here. So can we say it's a quadratic equation? No, because the definition of quadratic equation is that you should always see the maximum power of x should be 2 only. It cannot be 3, 4 or whatever, right? So if there are some extra terms in the equation which is having the some other power like 3 or 4 whatever, okay, then we cannot say that it is a quadratic equation. Second thing is that suppose you say, okay, sir, my equation is like this. It is having the suppose x square plus x is equal to 0. There is no number, right? There is no constant c in my equation. So, but you should always think uh, that about this term only. Okay, if there is a power of 2, maximum power of 2 in the equation, then that is a quadratic equation. You don't need to bother about whether the bx term is there or c is there, right? So for example, if you have x square plus 2 is equal to 0, right? So here we don't see the term of bx or x, right? So even then this is the equation which we can say as a quadratic equation, right? So the main concept which I want you guys to understand that in any equation, if the power of x is maximum 2, right, then only we should say that particular equation is a quadratic equation. So this is one basic concept about the quadratic equation. So now let's understand about roots, right? What are roots of the quadratic equation, right? So when we talk about roots, right, root means that what values, if you put them in this equation, suppose our equation is something like that. Example, let's see, 2x square plus 4x plus something 6, okay, equal to 0. So if you want to put some values in this equation, and that becomes 0, then those are called root, right? So if you talk about the standard form of the quadratic, like ax square plus bx plus c is equal to 0, so there will be two roots of this, because what how many powers are there? Two powers are there. That's why we will have two roots, right? We have uh, two roots. For example, if you're solving equation that is having the power of 3, right? Suppose x cube plus 2 is equal to 0, or maybe whatever. Okay. So because here we have power 3, so this will having the three roots, right? So in our scope, we will have only maximum of two roots. Okay. So sometime we see some questions where they say, okay, suppose you have a quadratic equation like this, and there are two roots. One is alpha, another is beta. Alpha, beta are the uh, Greek letters which we utilize in mathematics. So suppose you want to find out the sum of these two roots, then what we say alpha plus beta is equal to minus b upon a, right? So what we see the coefficient of x, b, and coefficient of x square as a, then find the value of this alpha beta, right? Similarly, if you want to find out the product of two roots, then what will you say? Alpha into beta is equal to C upon A, right? So these are two very important questions or concept. Always remember, because there will be so many questions coming in your exam based on this, right? So now let's understand the nature of root. So if suppose you find out the roots, right? So what nature they are, like if they are real roots or imaginary roots. So let's see about that, right? So so in Ascendant form, we write like this: ax square plus bx plus c is equal to 0, right? This equation you should learn by heart, okay? If you remember this equation, it's very easy for you to understand the whole concept. So now, if you have the equation like this, and you want to find out the nature of roots, right? So what we do, we first find the discriminant, right? Discriminant we'll find out. And what is the formula for that? That is b square minus 4ac. So if you find out the discriminant of your equation, then by finding the values, you can judge whether the nature of root is like if roots are real, or if they are the equal roots, or there are no real roots. For example, if we say the value of d, right, discriminant is greater than 0, or we can say that b square minus 4ac is greater than 0. It means that this equation will be having two distinct means different, okay, two distinct real roots, right? Real roots. So here, the point to be noted, which is very important to understand, is that the term here distinct, right? Distinct is very important. It means that whatever the roots you will get, I think you will get, I mean, you will get two roots, right? So those two roots will be different. They cannot be same. Okay. So whenever your discriminant or this b square minus 4ac is positive or greater than 0, remember this, you will get the two distinct real roots. Okay. Now let us see the second condition, where suppose you see that the d is equal to 0. It means that once you calculate b square minus 4ac, that is equal to 0. It means that you will have equal roots, right? So it will be, you can see that you'll be having the two equal roots, equal real roots, right? So roots are there, but they are same. Suppose you got a root as a 2 comma 2, right? So there are two roots because it's a quadratic equation, because quadratic equation is always having two roots, but they will be the equal roots, right? Next concept or next condition is when you find out that your discriminant is negative, right? Negative value. So what will happen in that case? Your b square minus 4ac will be negative. In this case, there will be no real roots. What will you say? You will say that there are no real roots, right? So there will be imaginary roots. I mean, that concept will come in complex number in class 11. But for your syllabus point of view, right now, you can understand these three things that whenever D is positive, it means you will have two distinct real roots. Whenever your D is equal to 0 or B square minus 4 is equal to 0, you will have two equal real roots. And when the discriminant is negative in nature, then you will have no real roots. Okay. So till now, let's revise what we have understood till now. Let's go back to our notes. So when we say a quadratic equation, it means that the highest power of variable should be 2, right? And the standard form of the quadratic is ax square plus bx plus c is equal to 0, where a not equal to 0. It means that a cannot be 0 because if a becomes 0, that will going to vanish the x squared term itself. So that will make this equation as a not like a quadratic equation, right? So that's why this is the equation we have to remember always. Now, to find out whether your equation is quadratic, I have shown some examples. Okay, we'll also do the exercise, all the exercises, and also get more familiarity with this concept. Then we find out that because it is a quadratic equation, so there will be two roots, right? So, for example, in our case, we should thought like okay, we have roots as alpha and beta, and suppose we have this equation for quadratic equation, then if you want to find out the sum of roots, then what we will say, if this is equal to minus b upon a and product equal to c upon a. So these are the concept about the roots summation or roots product, right? Then we also understood about the nature of roots, right? That is basically understanding the, we know okay we will get two roots, but what roots will be look like, maybe if there are two distinct real roots or two equal real roots or no roots, that concept or that nature of roots we can find out by the discriminant, right? So with this value you can find out the nature of roots. So if the value of b square minus 4ac is positive, it means that you will get the two distinct real roots. If the value of d is equal to 0, it means that there will be two equal real roots. But if the value is negative itself, it means that there will be no real root, right? I hope the concept till here will be clear, right? So now let's understand how to find out the values of roots in a quadratic equation, right? So as we know that the form of quadratic equation is like this: ax square plus bx plus c is equal to 0. So, if you want to find out the roots, then the one way is to simply find out by this: x is equal to minus b plus minus under root b square minus 4ac upon 2a. Okay. So by this formula, you can find out the values of root, right? Because you see here, right? there is a thing that we have a plus and minus, right? So it means that, so first time, suppose you are trying to find out the root 1, x1, right? So what you will say? X1 is minus b plus under root b square minus 4ac, uh, sorry, upon 2a, right? And second root will be x2 is equal to minus b minus under root b square minus 4ac upon 2a. So by this, we can find out the the values of two roots, right? So now just one thing you notice here, that there's a under root, right? There's under root b square minus 4ac, right? So now if you correlate this under root in this formula with the concept we just learned about the nature of roots, so if the value is negative, right here, negative, it means that something is negative under root, right? Something is negative here. So we cannot find the value because under root value inside under root will be always positive. So if there is something in under root, suppose we have under root p, then p should be always equal to greater than equal to 0, right? It cannot be negative. So it means that if your discriminant is negative, this part is negative, it means that there are no real roots. So now you can go back and correlate that if the value of b square minus 4ac is negative, it means that you cannot find the value of this whole term. That's why you are saying that no real root, right? No real root, because if the b square minus 4ac becomes negative, it's inside under root. And remember this concept that whatever value is inside the under root, that is always positive or zero. It cannot be negative. Okay. So for now, because there are some concept you will study in class 11 or later, but for now, at your level, class 10th maths level, right? Just remember this thing. If anything inside the under root, that should be always positive, or max to max, it can be zero. Okay. So this is the main concept here. So now coming back to the how to find roots. So by this formula, you can find out the roots of the quadratic equation, right? So this is how you can find out. There is one more way, which we call as a factorization method to find out the roots. So that we also see now. So in that, right, so what we do, for let me take an example here, right? So suppose you have a quadratic equation like this. You have 6x square, and then you have minus x minus 2 equal to 0. So one way is that what will do, we'll simply compare the values from the standard form, right? And get the values of A, B, C and put value in this formula and get the roots. But there's another way that is called the factorization method. That is, let us see that. So now how we do that in that case? So the equation is 6x square minus x minus 2 is equal to 0. So what we do, we multiply this term of x square and the constant term, right? So it shows 6 into 2 is equal to 12, right? And then what we do, we do the factors of 12. It means that 2 6 are 12, 2 3 are 6, and 3 1 are 3. So now, first step was to multiply the term, the coefficient of x square and the constant term, right? And then we got 12, right? Then what we did? We did factors of 12. Now we got 2, 2, and 3. Now our aim is that we have to write in such a way that when we use two terms, right? Those two terms will be such that their sum will be minus x, and their product will be minus 12 because 6 into minus 2 is minus 12. So now what we'll do, we will find out two terms here uh, whose sum will be minus x and their multiplication will be minus 12. So like this. So 6x is square plus 3x minus 4x minus 2 is equal to 0. So now you see that if you add these two terms, you get minus x because it's plus 3 and minus 4 is minus x. And if you multiply 6 into minus 2, you get minus 12, right? And similarly, to multiply 3 and minus 4, you get the minus 12, right? So, the multiplication of 3 and minus 4 gives minus 12, and similarly, you get also same with this 6 and minus 2. So, this is how we do the factorization of this term. And what we do, we take the common. Suppose we can take common as say 3x here. So it becomes 2x plus 1. Then now here we take common as say minus 2. It becomes 2x plus 1 is equal to 0. Now you can say that take this is common, and now you get the 2x plus 1 bracket 3x minus 2 is equal to 0. So now you have got two terms, right? 2x plus 1 multiplied by 3x minus 2 equal to 0. It means that either this is 0 or this is 0 because 0 into something is 0. So now let's see. Maybe we just assume that, okay, this is 0 now, first term. So 2x plus 1 is equal to 0. 2x is equal to minus 1 because this is going to this side, so become minus, and then x is equal to minus 1 by 2. This comes in the here, right? In here. So now you got the first root. Second root, now make it this as a 0. So 3x minus 2 is equal to 0. 3x is equal to 2, and then x equal to 2 by 3. Now you got the second root. So you got the two roots like this. So for finding out the roots of a quadratic equation, you have two ways. First way is you compare with this form of quadratic equation, get the value of a, b, and c, and then put in this formula and find the two roots. Or, if possible, if you are able to multiply these two numbers and get factors and find out the two number pair, that is giving sum as this and into as a number of these two numbers. So you can find out by this also. So I mean there are two ways to find out, right? So I think I have covered the concept on the quadratic equation, whatever in your course. So in next session, I will solve all the questions of exercise 4.1 and onwards. Thank you for watching. Please put comments in the comment box so that I can improve my teaching. And also, please share with your friends circle so that may be helpful for them as well. Thanks a lot.